Hello, dear students. Welcome back. I am Dr. Jyoti Shegokar, and today we will deal with the study of fixed bed catalytic cracking. As guys, you know that this topic is under the heading of catalytic cracking, which is one of the type of cracking where there is a use of catalyst with a temperature and pressure. It is called as a catalytic cracking. It is one of the very superior over the thermal cracking, which is another type where there is only temperature and pressure is applied. But here in a very less pressure, in a very less temperature, cracking is done. Guys, you know, cracking is nothing but the conversion of a higher molecular weight hydrocarbons, particularly gasoline, into the lower molecular weight hydrocarbons according to its change in state, according to number of changes are occurred there, and more superior quality petrol will be produced. So we will study today the fixed bed catalytic cracking in detail. Here those petrol or gasoline is produced is having a very high quality, like it is having a very good anti-knocking property. It is not moving towards knocking tendency, as well as it is having a good octane number. It is a very stable type of products are produced, particularly by the catalytic cracking. And in this, there are again two different types, fixed bed and fluid bed or moving bed. So we are going to study today fixed bed catalytic cracking. So without wasting a time, guys, we'll move towards our topic. Before that, if you like this video, like it, share it to your friends and subscribe this video, as well as hit the bell button if you need such type of videos in a very short time as soon as it uploaded. So moving toward this fixed bed catalytic cracking, I already drawn the diagram so as to save our time. See, here you can see very first compartment is a preheater just before the heating process. Second, catalytic chamber, or it is called as a catalytic tower. In this catalytic tower, catalyst you can see. At the same time, in this the heaters are provided, heating coils are provided, as we need the temperature also. So catalytic chamber is the second compartment. Then third is a fractionating column, where when once the oil is produced, the cracked gasoline is produced, it must be fractionated, it must be differentiated according to its quality. So fractionating column. Then after that, as it is in the vapor state, it is to be converted into liquid one. For that, particularly the coolers are provided. So in these coolers, the very high temperature gasoline is converted into low temperature gasoline, as well as it is cooled. Then when it is moving toward the next compartment, where there is a particularly condensing occurs, means all the gasoline is converted into all the type of liquid type of gasoline, and dissolved gases are also there. Then last compartment is the stabilizer, where all the gases are stabilized in the particular type of its according to its quality. So in this way, there is all the types of the construction is given. Now moving towards its working, exactly what will happen. So in working, first there is a preheater. Here guys, when we see preheater, means before the heating process, before the exactly cracking process, what will happen? It is not the direct process, but systematic process must be there. So for that, the preheater is there first. So here generally in preheater, temperature is 400 to 500 degrees Celsius. So that the crude oil or heavy oil, which is a heavy oil charge which is provided for the conversion purpose, it must be converted into vapors state, which is before the process of cracking. So here temperature, such type of temperature is given. So here the arrow or the way it is shown, it is towards the cracking process. As second compartment is having catalytic chambers. Now what type of catalysts are there? Generally catalysts are alumina, then silica, aluminium silicate, as well as some bauxite with a zirconium type of oxide. So all these are there in the very finely powdered form. So here you can see that catalyst vapors. So it is diagrammatically just shown there is a presence of catalyst. So At this very high temperature, that catalyst may be seen like a vapors, but it is in the solid state undoubtedly. And at the same time, here there are provided the heating coils so as to increase the temperature. Now in these heaters also there is a temperature of up to 500 degrees Celsius and pressure is of 1.5 kg per square centimeter. Such amount of temperature and pressure is provided, then and then only the gasoline can be cracked. So here only 30 to 40% of gasoline is produced. Means from the 100% of crude oil, 30 to 40% of gasoline is produced in any cracking process, while the carbon or the residue we can say is up to 4 to 5% residue will be produced. 3 to 5% is given, while the remaining is there in the form of uncondensed gasoline. Okay, now here just consider that there is a presence of this particular catalyst. Then in this the some heating coil is also given like this, and pressure is also provided. So here in this particular compartment of catalytic chamber, there occurs the process of cracking. That means higher molecular weight hydrocarbons are converted into lower molecular weight hydrocarbons in this chamber. And now once they are formed, but still they are in the mixture, though there is a formation of product, but it is in the mixture form. So that mixture must be differentiated. For that it is provided to the fractionating column, which is the very next compartment. So here as soon as this is provided to this fractionating column, here the heavy oil or the uncondensed gasoline, uncondensed oil will be settled at the bottom. So here it is given heavy oil charge. So that is not properly cracked, that charge is there. While according to the produced product, like for example methane is produced, it will get at the just uppermost side according to its state as well as according to its molecular weight. It will be there at the uppermost side, while before that below that there will be next like ethane, like propane, butane, propene, like that. So in this way it will be designed, or it will be just after fractionation, it will be just in this sequence produced. Then it is passed and here the some uncondensed gases which are there are totally get removed. So here when fractionation occurs, the gases which are produced, which are away from the gasoline, which are not condensed in the gasoline, are produced, are just passed away. Now from this the one by one all the types of products are proceeded toward the next container, which is called as a cooler. Here arrows which are shown there, they are for passing some cool air and removing some hot air. So here these arrows are there. While after this cooling, it is passed to the condenser, where all the type of gasolines are condensed according to its molecular weight. Now here also there occurs the cooling process, but exact condensing is in the next container, which is here I gave the heading as a gasoline plus dissolved gases. Means that condensed gases, though gases they are not a part of gasoline, but they are in the liquid state now according to the temperature change. And but the last container, it is a stabilizer. Actual that is bifurcation of gases and gasoline occurs in the stabilization or stabilizer, where from the lower side the cracked gasoline is produced, while from the upper side, whether there are some uncondensed gases, they will be removed. So in this way the total process of fixed bed catalytic cracking has been done. Here you can see that the catalyst which is there, after some time, after removing after using of that catalyst, and if it is totally get exhausted, we can say, as there is a presence of all the carbon residue in the catalyst, it is totally occupied. In that case, after some time the process is to be stopped, and then this particular catalyst is to be replaced by another one, fresh catalyst, and it can be regenerated also by passing a very high temperature, so that residue, carbon residue, it will be removed as a carbon dioxide or different type of gases by the process of burning or combustion. So in this way there occurs the fixed bed catalytic cracking. Guys, it is very easy to study and understand if once it is by the concentration, if we study it. So during writing in the paper, just write your introduction and somewhat about cracking, then its construction with a total explanation of the diagram, and then the working where there is how process occurs is must be there. And at last, advantages. It is a very good advantages or superior products will be produced by catalytic cracking instead of the thermal cracking, where there is some unstable type of products will be has been produced in case of thermal cracking. While in catalytic cracking, very good results are there, and products are also very stable as well as very much superior. Guys, with this, thank you for watching. Thank you for watching this video for today. Once again, we'll meet in the next video when we will study the fluid bed catalytic cracking. Thank you up to that particular moment. And if you not like the video, like it, share it to your friends and subscribe it. Thank you.